Folks, I got a good question about the homework, and so I thought I would answer it here and share with everyone. We're going to use the chain rule quickly to think about when you apply the rules. And remember, at the end of the day, we've only got a few differentiation rules, right? We know how to differentiate x to the power of n. That's the power rule. And we know how to differentiate sine and cosine and tan and the 6 trig functions we know how to differentiate. And what else? Well, that's about it. They're our basic functions that we know how to differentiate. Then we have the power rule. Sorry, we've got the power rule. Then we have the product rule and the quotient rule and the chain rule. They're building on that. But each of those rules has to end up down at the basic functions. So we keep differentiating and applying rules until we get to those basic functions that we know how to differentiate, like x squared or like sine and cosine. So let's look at this problem. This one uses the chain rule. And so to use the chain rule, what you always do is you don't change the outside and you look at the outermost function and you differentiate it. And the outermost function here is that x to the power of 9. So the derivative of something to the power of 9 is differentiated using our power rule, which means the 9 comes down and we reduce the power to 8. And then you multiply by the derivative of the inside. Right, so now I'm just going to write that entire inside down. I'm not going to actually do the derivative. You can, but in terms of thinking about the process, I'm just writing that whole derivative down, and then I'm going to write the derivative symbol. Because then what I have is a whole new problem. Right? I've got this original derivative that I've taken using the power rule. It's not going to change anymore. We never change the thing inside the function. So when we're doing derivatives of composite functions, which is what this is, the inside never changes, right? So we're going to get that each time. But then we're going to apply the chain rule here. Or to be fair, we're going to apply whatever rule applies, because this is an entirely new problem, right? Now I'm thinking about the derivative of this. This is just hanging around as part of our final answer. Now I'm doing a new problem. So I work through it. Is cosine of x plus 2, is that one of our basic functions? No, it's not. It's actually got a composition itself. So I'm going to differentiate the outermost function. Derivative of cosine is sine. And then put the whatever's on the inside back in, because that's what we always did, just like we did it there, and then multiply by the derivative of x plus 2. And the derivative of x plus 2, I'm not even going to do it, I'm just going to write it down, right? And then I'm doing the same thing for the next one. The derivative of sine is cosine, and then there's something that's not just x in there, so I have to multiply by the derivative of x plus 2. And then this is just one of the ones we know the rule for, so we can just do it. But you see how now I've viewed this as an entirely new problem where I apply the chain rule, the quotient rule, the product rule, whatever applies, and I did it using the chain rule here because I didn't have our basic function sine x or cosine x. I had sine of something more complicated. So differentiate it as if it was just an x on the inside, put whatever was there back, and then multiply by that derivative, and then do it for every term. Right? So then you can write out the final thing. And when we do that, pen stopped working. When we do that, you should end up with all of that stuff we started with before, right? And, there's a lot here, but you should write it all down. All of that's still in there, and then everything here is multiplied, and then we can take these derivatives that we haven't done yet, right? Again, this is a new problem. Differentiate. Well, we know how. X plus 2, that's easy to differentiate. Derivative is 1. Derivative of both of those is 1. So I'm just multiplying by that 1 here. All of that's multiplied by 1. I'm not even going to write it down. The next one is 5 cosine of x plus 2. I'm just multiplying by 1. I'm not even going to write it down. Times 6x. All of that's multiplied. There's our final answer. We're done. There's no derivatives left, right? Imagine if I'd changed this to an x squared and that to an x squared. So inside here we had an x squared plus 2. I haven't done any of these derivatives yet, so I would just have a squared there at each case. And I would be differentiating the squared there. Now at the very end here, I would have this last step would involve the derivative of x squared plus 2, which would be 2x. So you'd end up multiplying by 2x. You'd end up multiplying by 2x. And then you're done. There's no more derivatives to do. Okay, so you just follow one step at a time. Differentiate the outermost function, multiply by the derivative of what's inside, and then treat that as a whole new problem. It's just multiplied by what you saw before. Hopefully that gives you some idea of how to tackle some of these more complicated chain rule problems. See ya!